Hey everyone, welcome back to the channel. Today we're diving into the fascinating world of material science 101. Let's break down the basics of classifying materials and their properties. First up, let's think of iron, aluminum and copper. They're known for their high electrical and thermal conductivity, which means they're great at transferring heat and electricity. Metals are also malleable, ductile, and have high tensile strength, making them ideal for construction, electrical wiring and machinery. Moving on to carbon, sulfur and phosphorus. These materials are poor conductors of heat and electricity, and they're usually brittle and non-ductile. Non-metals are perfect for use as insulators and in the chemical industry. Next, we have examples include porcelain, brick and glass. Ceramics are known for their high hardness and thermal resistance, but they're also brittle and poor electrical conductors. You'll find ceramics in electrical insulators, construction materials and cookware. Then there are such as polyethylene, PVC and nylon. Polymers are low in density, good electrical insulators and flexible. They can either be thermoplastic or thermosetting. They're commonly used in packaging, pipes and textiles. Finally, let's talk about fiberglass and carbon fiber reinforced plastics. These materials boast a high strength-to-weight ratio and corrosion resistance. They can be tailor-made for specific properties, making them perfect for aerospace, automotive and sports equipment. Now let's get into these materials. Thermal conductivity is the ability to conduct heat. Metals have high thermal conductivity, while ceramics and polymers generally don't. Thermal expansion is the change in dimension with temperature. Metals typically have a higher coefficient of thermal expansion. Specific heat is the amount of heat required to change the temperature of a material by 1 degree. And polymers generally have higher specific heat than metals. When we talk about corrosion resistance is key. Stainless steel and aluminum are great at resisting corrosion. Chemical reactivity is the tendency of a material to react with other substances, with highly reactive materials like sodium reacting readily with water. And don't forget toxicity. Certain polymers and heavy metals can be harmful. For electrical conductivity measures a material's ability to conduct electric current. Metals like copper are excellent conductors, while ceramics and polymers usually aren't. Dielectric strength is the ability to withstand an electric field without breaking down, and materials like ceramics and polymers excel here. Semiconductivity is crucial for electronics, with materials like silicon being central to this property. Lastly, let's look at tensile strength is the ability to withstand pulling forces, with metals generally having high tensile strength. Hardness is resistance to deformation, with ceramics typically being very hard. Elasticity is the ability to return to the original shape after deformation, which is common in polymers. Ductility is the ability to be stretched into a wire, with metals like copper being highly ductile. Brittleness is the tendency to fracture without significant deformation, often seen in ceramics. And that's a wrap. Understanding these material properties helps in choosing the right material for specific applications, ensuring performance and durability. If you found this video helpful, hit that like button, subscribe for more content, and let me know your questions in the comments below. Thanks for watching.